Question 21 here. So we've got Jackson trying to find the density in grams per centimetre cube of a block of wood. The block of wood is in the shape of a cuboid. He measures the length, width and height, and each of them is measured to the nearest millimetre. As soon as you see nearest millimetre, what you've got to think about is having limits of accuracy. So the fact that it could actually be a bit more or a bit less than that. Now we've got 13.2 centimetres correct to the nearest millimetre, so it's the nearest 0.1 of a centimetre. What I'm going to do is I'm going to find my limits of accuracy there. So we could have been, so I'm going to take half a millimetre off, add half a millimetre on, 13.15, 13.25, same with the rest. Got to be careful with the 16.0, taking half a millimetre off is 15.95, adding on 16.05, 21.7, simple enough, 21.65, 21.75. The mass of the wood, 1970, correct the nearest 5 grams. Okay, so what we've got to do is, again, take half of that off, take 2.5 off, 1967.5, add 2.5 on, 1972.5. So we've got the maximum, minimum for the lengths, maximum, minimum for the mass. Now it says, by considering bounds, work out the density of the wood, give your answer to a suitable degree of accuracy. Now, just a quick reminder, density, mass, volume. Okay, so we want to find the density, you've got to do the mass divided by volume. Now, I've got to think about having the maximum density and the minimum density. So I'm going to think about the density, the maximum density. We'll do that by getting the maximum mass, dividing that by the minimum volume. Also got to do the minimum density, which is the minimum mass divided by the maximum volume. Okay, now we've got the maximum mass, which is 1972.5 grams. We've got the minimum mass, which is 1967.5 grams. We need to get the minimum volume and the maximum volume. I'm going to go down here a second. To get the minimum volume, got to imagine that it's each length is the minimum. Each length here is the minimum size. So volume of a cuboid, length times width times height. So 13.15 times 15.95 times 21.65. So we've got 4540.925125. Okay, now quite a long thing there. What I'm going to do is I'm going to store that. Okay, I'll store that as part A, just so I don't have to type it out again, but I want to use that exactly full value there. Maximum volume, again, I'm going to use maximum length, width and height. So I've got 13.25 times 16.05 times 21.75. So 13.25 times 16.05 times 21.75. That gives me 4625.409375. Again, I don't want to bother typing that out again. I'm going to store it. So I've got answer equals shift store. I'm going to click that with B. So that's B. Just double check. Alpha B gives me the same answer. Okay, so what I'm going to do is find my maximum density. So that was maximum mass divided by minimum volume. So 19.1972.5 divided by 4540, etc. So what I'm going to do is, what was it, 1972.5 divided by, now I'd stored that as A, so divided by A, get 0.43438, so on. 0.434382856. Now to find my minimum density. So my minimum density was the minimum mass divided by maximum volume. So change a few things here. So minimum mass 1967.5. Maximum volume I had stored that as B. Minimum density 425377546. Okay, now if we consider these got two slightly different values, but as I said, we need to work out the density of the wood, give your answer to a suitable degree of accuracy. Okay, now they both start with 0.4, that's fine. This is 0.43, 0.42, a little bit off. But if I round it to 2 decimal places, or 2 significant figures, they both round to 0.43. So whenever I want to find the density of the wood, I know that the maximum and minimum density both round to 0.43 to 2 decimal places. So that must be what the density is. So we can say density, definitely 0.43 to 2 decimal places.